Hello everyone, welcome back to the lecture series on engineering mechanics. Myself Dr. P. Pramod Kumar, Associate Professor in the Department of Mechanical Engineering, MLR Institute of Technology. Today we are going to discuss what are the components of a force, resolution of forces, and we are going to solve a problem on resolution of forces. Let us see first the components of a force. To understand this concept, let us take a body acted upon by a horizontal force. The effect of the force on the body is to move the body in its line of action. A horizontal force will move the body or will try to move the body in its line of action. This is the initial position of the body. Due to the application of force, the body may tend to move in horizontal direction. This is the final position. The effect of horizontal force is solely in horizontal direction. There is no effect in the vertical direction. A horizontal force will not affect the body in vertical direction. So this horizontal force has only horizontal component. The total force itself is its horizontal component and the vertical component is 0. Let us look at the second example. When a body is acted upon by a vertical force, the effect of this force on the body is to move in its line of action, that is in the vertical direction. This is the initial position of the body, and due to the force the body tend to move in vertical direction. The effect of a vertical force is completely in vertical direction and the vertical force doesn't have any horizontal component. A horizontal force has only horizontal component and a vertical force has only vertical component. Here the vertical component is 0 when the force is horizontal, and when the force is in vertical direction its horizontal component is 0. Now look at another example. What happens when the force is inclined? When an inclined force is acting on the body may tend to move in its line of action. This is the initial position and the body will move in its line of action. The body will tend to move in its line of action. This is the final position of the body. Here the effect of inclined force is in both the directions. It translated or its effect is in horizontal direction as well as in vertical direction. That means an inclined force has both horizontal and vertical components. Now let us see how to find these horizontal component and vertical component for an inclined force. The process of dividing a force into two mutually perpendicular components without changing the effect on the body is called resolution of forces. Without changing the effect on the body, dividing a force into two mutually perpendicular components. For example, a force 10 newtons is acting at an angle of some 30 degrees to the horizontal. If you split the force into two mutually perpendicular components, let us say sigma h and sigma v, if you find the resultant of these two components, sigma h and sigma v, you should get the resultant 10 newtons acting at 30 degrees to the horizontal, that is what, without changing the effect on the body. Now let us see how to find the components of a given force. Take this example, a 10 Newton force is acting at 30 degrees to the horizontal. To find the horizontal component and vertical component, construct a rectangle ABCD in such a way that the force 10 newtons is the diagonal of the rectangle. Construct a rectangle ABCD in such a way that here the horizontal side of the rectangle represents horizontal component and the vertical side of the rectangle represents the vertical component. So in this rectangle, the vertical component is vertical component of the force and the horizontal side is horizontal component of the force. Now let us measure or calculate the horizontal side, length of horizontal side and vertical side. To do that, I will take the horizontal side is adjacent to theta, adjacent to angle 30 degrees. So I will take cos 30. Cos 30 is equal to AB by AC. AB is my horizontal component. AC is the diagonal of the rectangle, which is nothing but force 10 newtons. Now from this we can calculate the horizontal component H. The horizontal component is given by 10 cos 30. Now coming to the vertical component, here the vertical component is nothing but CB, which is opposite side. So I will take the opposite side, that is sin 30. Sin 30 is equal to opposite side by the hypotenuse of the right angle triangle ABC. Here the vertical component is nothing but 10 sin 30. The horizontal component of 10 Newton force acting at 30 degrees to the horizontal is 10 cos 30 and the vertical component is 10 sin 30. Now look at another example. The same force 10 newtons and it is acting at same direction. Instead of representing the angle with respect to horizontal, that is 30 degrees to the horizontal, now I will represent the force, the direction of the force with respect to vertical. The same force is making an angle of 60 degrees to the vertical. Now let us see how to find horizontal component and vertical component. Construct a rectangle in such a way that the given force is the diagonal of the rectangle. Now for the given angle 60 degrees, the horizontal side is in the opposite direction. See here, CD is in the opposite direction, is in the opposite side to the given angle 60 degrees. CD is equal to AB, which is our horizontal component, and the side AD is now adjacent to the 60 degrees. Now I will take cos 60. Cos 60 is equal to AD by AC. AD is the adjacent side now, which is nothing but our vertical component. So the vertical component can be calculated now by using V is equal to 10 cos 60. In the earlier example, The horizontal component is 10 cos 30 and vertical component is 10 sin 30. Here the vertical component is 10 cos 60. The values are same. The values are same. But here in this case, in the previous case, we got cos theta in the horizontal component and now we got cos theta in the vertical component. Now look at sin 60. Sin 60 is equal to DC, opposite side, which is equal to AB, our horizontal component. DC by AC, here horizontal component is 10 sin 60. 10 sin 60 and 10 cos 30 both are equal. The force 10 newtons magnitude is not changed and the direction is also not changed. Only the representation of its direction with respect to horizontal or vertical, the representation is changed. When the angle is given with respect to horizontal component is cos. When the angle is given with respect to vertical component is cos. So with this concept, we'll move on to do a problem on resolution of forces. Find the magnitude and direction of the resultant of system of forces. Here is the system of forces. This is a coplanar concurrent force system. To find the resolution, to find the resultant of the system of forces, we will use the concept resolution of forces. We will resolve the given forces into two components. One is horizontal component and vertical component. After finding that, we will calculate the resultant by using the formula for two forces. Let us see the solution. Here, the 25 Newton force is exactly horizontal. It doesn't have any vertical component. Its horizontal component is the force itself. See here in the resolution, for the horizontal components we have the sign convention like this: right side positive, left side negative. For the vertical components the sign convention is like this: upward positive and downward negative. We can change the sign convention like left side positive and right side negative, downward positive and upward negative. But till completion of the problem, we need to follow the same sign convention. Now, consider the 25 Newton force. The 25 Newton force is horizontal force. We already understood that a horizontal force don't have any vertical component. The horizontal component is the force itself. 25 newtons is the horizontal component of this force. Now, look at the 20 Newton force which is acting at 30 degrees to the horizontal. Here the angle is given with respect to horizontal. Therefore, the horizontal component is 20 cos 30. The horizontal component is 20 cos 30 and the vertical component is 20 sin 30. Now, resolve the 10 Newton force. Here the angle is given with respect to vertical. So, our vertical component will be cos and horizontal component will be sin. Now, look at the direction of the force. It is a push. Look at the arrowhead. It is a push. Now, let us see the effect of this force on the body. If this force is acted on a body, it may affect in its line of action. That means the line of action is towards right and downwards. That means the horizontal component is acting towards right side and vertical component will act towards downward. So for this force, the horizontal component is 10 sine 40 because the angle is given with respect to vertical. So vertical component will be cos, horizontal component is sine. Now the vertical component is 10 cos 40. Now look at another force 45 newtons which is making an angle of 20 degrees to the horizontal. The horizontal component for this force is 45 cos 20 and the vertical component is 45 sin 20. Here the effect of this force is in its line of action, that is the arrowhead is showing towards left side and downwards. So the horizontal component will be towards negative left side 45 cos 20 and the vertical component will be downwards 45 sin 20. Now look at the last force 35 newtons. This 35 newtons is acting exactly vertical in upward direction. This force don't have any horizontal component. The vertical component is the force itself. So 35 newtons is acting in the vertically upward direction. Now write the equation, that is algebraic sum of all horizontal components sigma h. Sigma h is equal to 25 plus 20 cos 30 plus 10 sin 40. This 10 sin 40 is also pointing towards right side. Its effect is towards right sides, that's why it is positive. And 45 cos 20 which is acting towards negative direction. Now calculate sum of all horizontal components. Its value is 6.46 newtons. Similarly calculate sum of all vertical components. The sum of all vertical components, see, 20 sin 30 and 10 cos 40. Here the 10 cos 40 is the vertical component of this force 10 newtons because it is affecting the body in the negative or downward direction, and downward direction we assumed negative, that's why it is minus. Similarly 45 sin 20 is the vertical component of this 45 newton force which is acting in the downward direction vertically. So its vertical component is also minus sin 45 sin 20. Now 35 newtons is acting in the upward direction, so it is positive. The sum of all vertical components is given by 21.95. Now all the forces acting on the body are resolved into horizontal and vertical components, and finally we found one horizontal force, horizontal effect of combined horizontal effect and net vertical effect. Now sigma h is 6.46, sigma v is 21.95 newtons. Sum of all horizontal components is 6.46 and sum of all vertical components is 21.95. Now let us find the resultant for these two forces. We know how to find or what is the formula for finding the resultant of two forces acting at right angles to one another. R is the resultant and alpha is the angle made by the resultant with one of the forces. The formula for finding resultant of two forces when they are acting at right angles to each other is given by R is equal to under root sigma h square plus sigma v square. Substitute the values of sigma h and sigma v in this equation. We'll get the resultant 22.88 newtons. And let's find the direction of the resultant. The direction, the angle of resultant will be given by the formula alpha is equal to tan inverse sigma v by sigma h. Substitute the values of sigma v and sigma h. We'll get the alpha value 73.6. This is how we can find the resultant of number of forces acting on a body by using the resolution concept. In this video, we have learned what are the components of forces, and we have seen how to resolve a force into two mutually perpendicular components, and we have solved a problem on finding the resultant of system of forces by using resolution of forces. Thank you.